All right, so our fifth question, back to black. Fifth question asks us, expand using the rules of logarithms, then differentiate. Asking us specifically about y is equal to ln 7x divided by 2x minus 3. What's following this question? I'm not sure we'll need. Probably see it come up somewhere in the solution as we go along. Okay, so the first thing that we can do here is separate the log function. Sorry, the ln function, it's not a log. And for that, we can use the ln rule, or the ln law, quotient ln law specifically. I have to remember how to spell that. Quotient ln law. And that states that the ln of x divided by y is equal to ln x minus ln y. Okay, so let's see how we can apply that to our equation. So we have y equals to, well, I don't need to write it again since I have it right here. But yeah, we have two values divided by each other. So if you imagine this as the x here, and imagine this term as the y here, then we can write it easily like this: 7x minus ln of the denominator, which was 2x minus 3. All right? So now that we separated it, it will be a little bit easier to take the derivative. So that's what we're going to do now. Take the derivative. And so dy, oops, keep hitting things with my hand. Dy by dx is equal to d or dx of this whole function here, ln of 7x minus ln of 2x minus 3. And since these two are being subtracted, you can separate this derivative into d by dx of ln 7x minus d by dx of ln 2x minus 3. Okay, I just separated it because they're just being subtracted, so they don't need to be considered as one full term. And this makes it a little bit easier to understand. So I'm going to separate this into two parts just because it might be a little bit clearer this way. Also, I'll show what the solution does here. The solution goes into a little bit more detail than I think is necessary. But you can try doing it this way if you'd like, just by letting, so what the solution does is we'll start with 1 here. So this first term, which is d by dx of ln 7x. And like I was saying, this solution lets u equal to 7x. So then what you're doing is taking the derivative of ln u, right? And that's pretty simple because it's already a known function, right? I'm going to leave that out so we can go through a little bit more quickly because I think it's fairly easy to understand. But if you need it, it'll be here on this left side. Okay, so the derivative of ln 7x is, well, we know the derivative of ln is 1 over x, but in this case we have 7x, so we'll put that in the denominator. And since we have 7x, we have to also take the derivative of what's inside the ln function. So the derivative of 7x is just 7. So since there's 7 and 7, they will cancel out, and you'll just get that that's equal to 1 over x. All right, so now we can move on to the second half here. That's what I have, or the second term, I should say. They also sub in v for 2x minus 3, but it's the same process as 1, so let's try that. 1, 2x minus 3, so that's just the second term from what we have above. Hopefully I'm not blocking it. And it's the same process, like I said. So the derivative of a ln function is just 1 over x, or in this case we have 2x minus 3, times what is the derivative of 2x minus 3. So 2x, derivative of that is 2, and the derivative of minus 3 is just 0. So it would be,